Okay, so this counter value is nothing but your V try peak. So let me repeat again. How did I get this switching frequency information? So from vehicle speed, we calculated maximum motor speed requirement. From that, we calculated maximum modulating frequency requirement. From that, we calculated what is the minimum carrier frequency required. Okay, and then we generally do some optimization around it to find out required switching frequency. So once I know my required switching frequency, I know time period of the carrier signal. Okay. Once I know time period of the carrier signal, so then V try is nothing but for a sawtooth. V try is nothing but TS. TS is the frequency of the carrier waveform by T clock. So T clock comes from microcontroller data, and TS comes from your desired switching frequency. So that's how your V try peak gets decided. Okay. I hope you're getting the idea, right? So these are all hardware dependent things. So in microcontroller nowadays, we have to just do drag and drop. All these things are given. You have to decide what is your switching frequency requirement, and automatically V try is getting decided. Okay. So I'll pause for 30 seconds. Let me know if you have any question in this. So stepwise, we are going to first decide the switching frequency. That will decide the peak of the carrier based on the clock frequency of your microcontroller. And once you have decided the V try peak, your V modulating signal is going to be within that range. That's how we are going to design our speed controller. Alright, let me check. Of course, for sawtooth I showed you. For triangular, there will be a factor of 2. Okay, so I think these things are discussed. So there is a question how to select limits value for the limiter. So now I hope it is very clear. Once we have decided the V try peak, that will be the peak limiting value for the limiter, right? How to decide switching frequency? So as I told, minimum limit will come from 21 into maximum F mod, and maximum range will depend on your switching frequency limitations of MOSFET or IGBT that you are deciding. Thumb rule typically around 10-20 kilohertz. So there was another question. The peak values were decreasing after some time, and then other phase getting its peak. So see, for a sinusoidal signal, its peak value is only one value, right? So I don't know from where you're getting confused. So Mr. Thalla Gopichand, are you from electrical background or non-electrical background? If you can just let me know, I'll rephrase my statements accordingly. Mr. Thala Gopichand, if I pronounce your name correctly, let me know you're from electrical or non-electrical background. I don't have the answer. In between, Mr. Yes, sir, electrical. Okay. So then I can give you short answer. Thank you for that. So first thing you ask, the peak values were decreasing after some time. I don't know with respect to what. So let me first take up that diagram that will help me. Maybe you are referring to this one. Just give me a minute. Please communicate whether you are referring to this diagram. Do you mean this diagram? Yes or no? Just can you mention? Yes, very good. So in this diagram, for a AC signal, if you are from electrical background, you know that for a AC signal, AC repeating signal, its peak value is this value, right? This is the peak value. So for this entire signal, it has only one peak value. I hope this point is clear. Or you have some other understanding. So in between Mr. Mohammad Shadab asked above question, I was asking limiter which is used after PI control, how to select the. So that's what I already told, sir. I'll come back to you. So let me complete Mr. Gopichand's question. Right. So for every sinusoidal signal, there will be a single peak value, right? And all these three modulating signals, they're going to have three peak values, and all of them peak values are going to be same for a given operating condition. It may vary time to time, but three of them will have same peak value. That's what I'm trying to say. If one of their peak values are changing, other two signals, their peak value will also change, right? So that is first thing to make clear. If I understood your question correctly, then is there any power change on that time? That is again so that is the question I'm not getting. The peak values were decreasing after some time. From where you are getting this information? So is it okay if I give you mic access after the class to understand this question, because it is a long question? I may miss something and I may give you a wrong answer. I don't want that. So if you don't mind, I'll give you mic access and then we'll discuss it, right? We'll clear on that. Coming to Mr. Mohammad Shadab questions that I already discussed, but then let me repeat again. It's an important point, not to hurry. So in the PI controller, you see how many limiters are there. So you can see there are two limiters, right? One limiter is setting this modulating signal. So this limiter peak value, even if it is not. So this limiter, how do you design is a limiter looks something like this. Okay. So this is its positive limit and this is the negative limit. So this positive limit, we are going to set it V try peak value, and this negative limit will be minus V try peak value. I hope this point is clear. There is one more limiter here. This limiter value we are going to select based on T max of motor. So this fast PI controller, it is setting the torque reference, right? So can a motor generate any amount of torque? No, it has its own rating. So I should not ask a motor to generate more than its rated torque. Simple. That's why first limiter value we are going to set it at T max of the motor. I don't want my speed controller to generate a torque command desired value more than the motor capacity. It doesn't make sense. So that is our first limiter we are going to set. Second limiter is directly deciding my modulating signal value, right? So this limiter we are going to set based on V try peak. It is, though I am using a symbol equal to, you can say it is proportional to, okay? Because there are some other factor also in this second block. So if I just assume for time being it is a gain of 1. Alright, so then this block will correspond to, it will be decided such that modulating signal maximum value it can go is V try peak. This is simple maths, nothing else. I hope this point is clear. Okay, very nice of you. So Mr. Thalla Gopichand, I am very sorry, I could not clear your doubt. I'll give you mic access and we'll take care of it. Okay. So till now, what I discussed is how do you decide this carrier frequency, carrier peak, right? And next part is why did I talk about modulation index? That let me discuss. That is very important part. Okay. I'll skip through some slides. So why this quickly revision about MA is very important. Let me remind you again. What is MA? MA is the ratio of peak of modulating signal by peak of triangle carrier. Okay. What is the range of MA? 0 to 1. Okay, because we vary the modulating signal using speed control loop, whereas triangle signals remains the same. Okay, that's why modulation index varies. How does it impact output voltage? So here is the answer. So ultimately, in our inverter, we have a DC voltage VDC. We have output voltage total 3 lines. Let us call them A, B, C. So if I measure voltage between any 2 lines, let's say VAB or let's say VBC. As we know, any voltage is measured between 2 points, right? It is potential difference. So any potential difference between 2 lines like AB or BC, they will be same. Okay, so even and for between A and C, we can have VAC or VCA. So in a balanced system, this VAB is going to be VBC, is going to be VCA or AC. These are the RMS values here. Okay, they are going to have same values in a balanced system. The desired operating condition. So all these, we call them, these are known as line to line voltage. Okay, basically each of these 3, we have total 3 lines. So if you connect a voltmeter between any 2 lines, that is line to line voltage. Okay, so this, the way we are going to do this PWM, VRMS, okay, line to line fundamental component. Try to understand these terminologies. Let me also write it down in a separate slide to make things more clear. So what I'm trying to say, VRMS. RMS, I believe everyone knows, root mean square. We also discussed it earlier. And again, a first year basics. Even it is taught in class 2, 11, 12s. VRMS, line to line fundamental. This term indicates line to line voltage. And fundamental indicates fundamental frequency component. Okay, so basically you will see that this VAB or this line to line voltage, how they look like, they will look something like this. This is that VAB line to line, how they look like, okay, instantaneously. So this is actually lowercase VAB line to line. Remember, lowercase signal, when we write like this, it is the instantaneous value. Okay, it is changing in time. So basically you can see this kind of signal, right? We write VT. It is changing in time. And then we write the expression as Vm sine omega t. So it is varying sinusoidally, that's why sine omega t, right? And Vm is the peak value. Vm. So with respect to that 0 line, this maximum value is Vm. And Vm by root 2 is VRMS for sinusoidal signal. Okay. But in inverter, since we are doing a lot of switching, what happens is that this output line to line voltage, it will have basically pulsating phenomena. So basically it will have this kind of waveform, then this, and then again this. Okay. So output of the inverter, the voltage that you are applying to the motor, it is not going to be a pure sinusoidal waveform. All right. So you can, using Fourier series, you can make it approximated like this, a sinusoidal signal. This is known as the fundamental component. Fundamental component plus harmonics. Fundamental is only that blue. Okay, and plus harmonics, these two is that red colored waveform. both of them together. So it is like, simply think about it. You have some milk, you have some water. If you mix them up together, right, that is that red colored thing, which is generated at the inverter output. If you can separate out the milk, let's say the desired component, okay, so that is the concept. That then milk part is the fundamental component. So for torque production, for power delivery, etc., this fundamental component is more relevant. Again, these are all a lot of fundamentals inside. I don't want to go deep into it. It will take another 3-hour lecture. So just simple term, okay, think about this milk and kind of water analogy mixed together, right? Desired thing and some unwanted things together. Let's say you want only milk, so adding water is unwanted things, right? That is kind of harmonics here. So inverter output, it will have fundamental plus harmonics. So let me write down very clearly. Inverter output voltage, it will have fundamental, which is the desired thing, plus harmonics. Okay. So this only fundamental component, that value and its RMS value line to line is given by MA into VDC.
Disconnected.
क्या हुआ?
पता नहीं क्या हुआ।
अरे रहोगे तो देखोगे नहीं क्या हुआ।
बंद कर दो, पता क्यों लैपटॉप बंद कर दो, ये बंद कर दो। बड़ा कच्चा नींबू आंटी यहाँ पे लिया देखो अपने